This is Geometry Semester 1 study of circumference and arc length, and this is from Apex. This is lesson 5.71. Okay, on this lesson, don't forget the things that you already know. So for the first thing it asks us to do is to define circumference. The circumference is nothing more than the distance around a circle. That's it. The distance around a circle. Whoops, picked the wrong word. There we go. All right. Attempting to do this without a stylus. I got this, the distance around a circle. So when we look at the circumference formula, and it's on your formula chart, ask me if you need a copy of one. Okay, so the C in the circumference formula stands for, you guessed it, circumference. All right, let's get it written up here. I want to type it so it's nice and neat. Circumference. Boom, C is for circumference. And that's all we got to know. And then R, I hope you knew that R stands for the radius. Radius. And pi is going to be 3 for the case of this. I noticed that they don't really use the pi symbol on the calculator, but it's 3.14, and I don't want your quiz questions to be off. So on here, whenever you're asked to use pi, just go ahead and use 3.14. So the relationship between the formula that you know for circumference, 2 pi r, and a diameter. You know that the diameter is 2 times the radius. Well, if the diameter is 2 times the radius, then it's just 2r. Notice that the circumference equation has 2r. So if 2r equals d for diameter, then the circumference equation, if you are given a diameter, is just pi times diameter, or diameter times pi, whichever order you want to do it in. This problem right here, I feel like the steps did way too much. So here's how I find the circumference of a circle. What is the circumference of the circle? So we're given that the radius is 5.8. So again, if all you're given is the radius is 5.8, and we know the circumference equation, the circumference is 2 times pi times the radius, when all you're given is the radius. So for the examples here, we said that we would use 3.14 for pi. So this is going to be 2 times 3.14 times 5.8. All right, and I'll just put these in parentheses because my dots don't seem to be coming out as well. So grab your calculator. 2 times 3.14 times 5.8. And after double checking my work, I got that the circumference in this problem is 36 and 42 hundredths. So 36.42, which is 36 and 42 hundredths. Let's go. As I mentioned a second ago, don't worry about all the steps that seem to be at the top part. We already covered that. We know what our final answer is. So then you have this study problem called raising the road. And what it is that you want to know is how much longer the road will be after it is raised 50 feet. So that's what we need to know. We need to know how much longer the road would be after it is raised 50 feet. The old road and a new road are both circles that go around the world. The new road radius will be 50 feet longer than the old road. So that's something that we need to concentrate on. We know it's going to be 50 feet longer. So as we keep it moving, the problem is about comparing the distances around two circles. So if you need to know the distance around a circle, we can use the circumference formula to solve it. So let's get to writing. Circumference. Boom. All right, and circumference won't fit there, so I'll just put it to the side and do one of those numbers. There we go. So write the equations. Step 3 says solve the problem. We're going to write the equations and define the variables. So the old road has a circumference of 2 pi r, and the circumference of the new road is just circumference equals 2 pi r for the new road. So on these lines, what you're going to write is going to seem a little redundant, but the word circumference, and I need to switch this to black ink. So the circumference, black ink. Wow, TV show. All right, so the circumference of the O is circumference. Gotta keep typing. Of the old road. Boom. All right, that's what goes here. That's the circumference of the old road. And then the circumference of the new road would be C sub new. When you see the little word in this lowercase, then they're just talking about a subscript. So C, circumference of the new road. Boom, 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 boom. Try to make it fit as best as possible. If it won't fit, then hey, we're not gonna stress about it. It's all good. We just do our best. So the radius of old and the radius of new, that's the radius of the old road and the radius of the new road. Let me see if I can try to make my letters a little bit smaller. Let's go down to 20. All right, let's give it a shot. Radius of the old road. Boom. Put that right there, and it fits. All right, and then the radius of new is the radius of the new road. Radius of the new road. Boom. All right, so the next step, it says to combine and simplify the equations. So the circumference of the new minus the circumference of the old is going to be still equal to 2 pi times, whoa, that looked bad, 2 pi radius of new minus the radius of the old one. So when we substitute it in, the radius of our old plus 50, because the new road is going to have a radius that will be 50 feet longer than the old road. So once we calculate everything, we end up with 100 pi. And once we estimate it, the Magellan Global Highway will be about 314 feet longer after it is raised 50 feet off the ground. Arc length. Define an arc length in about 15 words or less. So the arc length is just the distance around part of a circle. That's all it is. The distance around part of a circle. Not city, circle. All right. Boom, boom, boom. There we go. All right, so that's the arc length. Pretty soon we're going to talk about the arc measure. Just hold on to your horses because we got this under control. So example A, the arc covers half of a circle. So if in example A, the arc covers half of a circle, let's say the circumference is 20. Then let's get to writing. It says the arc covers half of the circle. Where am I getting this information from? I'm glad you asked. Right there. It was given. So if the arc length is half of the circle, then the circle has a circumference of 20. So half of 20 is going to be my arc length. So that's a 20. It looks like 26, but it's a 20. So it's 10 centimeters. Now, for example B, the arc covers 1/4 of a circle. Glad you asked where I got that from. It came from right there. So the circumference here, the circle has a circumference of 32 centimeters. So the arc covers 1/4 of the circle. And if it covers 1/4 of the circle, then the circle is 32. So I'm multiplying. Of means multiply. So 32 times 1/4 is very similar to 32 divided by 4. So that's how they got 8 centimeters. In conclusion, to find an arc length, find a fraction of the whole circle's circumference. All right, so we're going to fill in the blanks. The arc length formula. This formula, don't let this bother you, is the length of the minor arc AB is equal to the measure of the arc AB divided by 360 times the circumference, which is 2 pi r. So if given, the measure of AB divided by 360 is equal to just a fraction, and that's what goes here, a fraction of the circle covered by the arc AB. So 2 pi r, once again, is going to be just our circumference of the circle. That's all. All right, let's put it in practice. Well, we don't get to practice just yet. That was me getting excited. So here we go. What does the measure of an arc and the length of an arc have in common, and what's different? So the measure of an arc is equal to the measure of the central angle that intercepts it. Don't let this bother you. Of course, we're going to practice it in just a minute. So the measure of the arc is equal to the measure of the central angle. And when we measure an arc, we're actually going to use degrees, just like we would for an angle. Because if the central angle equals the arc, we measure angles in degrees. We're going to measure that arc in those same degrees. So the length of an arc, here's where we do something different. It's equal to the fraction of the circle it covers multiplied by the circle's circumference. So once again, we got the C word, CIR, boom, the computer knows it. And this is measured in units of length. Don't let that bother you. For length, we use inches, feet, yards, meters, those different types of things. Okay? Now we get to put it in practice. So our direction says how to use the arc length formula. Where am I reading? Right here. So what is the length of the arc AB, the minor arc? So step 1 says use the given radius of or diameter to find the circumference of the circle. So 2 pi r, our radius here is 4. So I was plug in the radius, which is 4, right into that equation, and I get 25.12 or 25 and 1200ths. Then the measure of the arc AB, because it's a central angle, that angle equals 60. So right here on this line, I'm going to put 60 over 360, and that's equal to 1/6 of the circle. So, I'm sorry. Step 2 said use the given central angle to find what fraction of the circle the arc covers. So that's where the 60 came from. It was given. Step 3 says multiply your results from step 1 and 2. Round your answer to the nearest hundredth if necessary. So 1/6 times 25.12, and we ended up with 4.19 or 4 and 1900ths. So that's our final answer right here. 4 and 1900. That's a little decimal point in between a 4 and a 1. All right. Okay, if you were having some trouble with practice number 13, this is the exact same problem, and this is how it's actually taught in the classroom. So we take a part over whole equals a part over whole, and we solve it as a proportion. So we first look at the angle side of things. So with this side over here, let's say I'm going to kind of try to make this a constant. This is the side where we look at the angles. So with the angles, my part of my angle is 60 degrees. Now, the whole angle inside of a circle is 360 degrees. Now, as far as the part that we don't know, we were looking for the measure of the arc AB from here to here, and that's okay. So we don't know that part, so we call it X. But we do know how to find the whole distance all the way around the circle. The whole distance all the way around the circle is 2 pi, and our radius in this case is 4. Now that you have that kind of set up to something familiar, you can go ahead and cross multiply. I always like to give the students the part that I think would be easily recognized. So 360 times x is 360x. And then I do the difficult part. 60 times 2 times pi times 4. I'll go ahead and put that inside my calculator. And I got 1,507 and 2/10. That's a decimal right there. And then the last step with a proportion, you cross multiply, and then your last step is going to be to divide both sides by 360. And once I did that, I know that x is equal to 4.19. That is just another way how to solve that problem. If you need some help, please let me know. That's why I'm here, just for you. go ahead, give yourself a chance, look at those practice problems, and like I said, if you need help, that's why I'm here. Thank you.